All right, I'm going to call that my cue. Thank you all for coming. I'm Jon Lehtinen, and let's talk about automating your identity and access management infrastructure and operations. Specifically, this is the story of how we built our own identity as a service here at Thomson Reuters. And by way of background, the year is 2018, and Thomson Reuters decided to sell its finance and risk business, or divest it in a joint venture with Blackstone, to create something called Refinitiv. And God bless the lawyers, they decided to send a lot of our identity systems out the door with Refinitiv. Now, this was a great opportunity because we got to build new things for Thomson Reuters. At this time, I was one of about maybe 8 folk on the enterprise identity team, and I was responsible for the single sign-on and multi-factor piece of this. So I was tasked with figuring out what our new enterprise SSO and MFA solution would look like. Now, the timelines we had to work within was we got the flag drop to start working on this in April with a deadline to get it in production by the end of December. That's an aggressive timeline, but not an impossible one. There's some complicating factors along the way that we're going to get into in a moment. But joining me on this journey is Alyssa Kelber and Sean Farrell. In a move that calls into question her judgment, she decided to switch careers into identity during this project. And my longtime friend and colleague across multiple organizations now, Sean Farrell, joined in and put a lot of very fine technical touches on the solution we came up with. So during my time in enterprise, I've had the opportunity to work both on engineering side and operational side. And I swear by my life and my love of it, I will never take another ops call again. So we are 3, or were 3, and it wasn't so much finishing this within 8 months that I was worried about. It was more the long time support of it. I really do not want to have to support this environment, get woken up in the middle of the night, worry about it failing or anything like that. So, there we go. So we start thinking in terms of how can we design a solution which will be resilient enough that we don't need to worry about that. So let's consider the landscape in which this solution would operate. Thomson Reuters, after the divestiture, has about 35,000 users. The app count changes every time we say it out loud, but if we say there's 2,000 apps, they have lesser environments. Let's say 4,000 apps, which will need to use this environment. There's significant user populations across every single continent. And something that I've noticed in a lot of enterprise deployments is you don't care about user authentication experience if you're not in the United States. I thought this was an opportunity to actually give a delightful user experience to everybody in the world for a world organization. And I figured if something like the SSO platform could design for a global user experience, it'd be an invitation for application teams to do the same. Also with this, there was an opportunity for us to synergize with some additional corporate strategies like closing out our data centers, most of which were exiting the door with Refinitiv anyway, and also aligning with our cloud-first strategy moving forward. The current state was something special. There's lots of different user ceremonies, usernames, all sorts of things that just kind of wear folk down as they bump into them. You usually have to discover what kind of login you're going to use as you bump into the login form. What's even more fun is our web access management solution didn't speak any protocol that is standards-based. So migrating apps out of that was going to be a bit of a challenge, but there's an opportunity to go ahead and move us to where we really want to go, which is consolidating all these Thomson Reuters identities into a single username and password. I mean, not just to improve the user experience, but of course that is very significant. It also gives us a single thread of identity with which we can follow our users through all of their systems and feed information to our information security teams so we can track all their activities. Also, we want to move to standards so that way we can eventually rip and replace, not be hemmed in by any one particular integration point or anything. Also, I want multi-factor to be a function of our authentication service. I don't want it to be some proprietary or radius-based thing that privileged applications have to do a difficult integration with. I want it to be something that we can offer to all the applications so they could step up their level of assurance at authentication time. So, we start investigating the potential solutions here. And we start looking at on-prem, hosting an on-prem type product inside of a cloud-based environment, or going for the easy answer, which is, of course, IAWS. Now, these are the criteria by which we started looking at them. When I say self-service, I mean self-service for service delivery. like app integrations and whatnot. Again, we were only 3 people, so we want the service delivery piece to be as automated as possible. Work in other organizations has shown that as long as the application has APIs and whatnot, automating self-service is achievable with almost any platform. Considering the strategic alignment of these platforms, obviously on-prem is a no-go if we're moving to the cloud. Making something globally available for on-prem or cloud-hosted is honestly, that's a function of your enterprise architecture. I don't really have much of an influence there. But IDaaS, actually, despite having global deployments, there's no guarantee you're going to get a globally respected session out of a lot of IDaaS vendors. That was surprising. And then finally, the thing I cared the most about was the operational effort of supporting these things. On-prem necessitated interacting with a whole bunch of third-party managed service providers to do everything, and that would just introduce friction and delay and all sorts of problems. Cloud-hosted is a little bit better since we would manage the cloud backplane. IDaaS obviously would be very great because we're functionally outsourcing it. But the real rub is, the cost. And if we spend a whole ton of money on IDaaS, that's less money we can use to reinvest in the business to help those applications get out of the old and into the new. We only have 3 years or so to migrate all of the business processes into these new systems before we are legally obliged to sever our connection to Refinitiv. So any money we could save during the build could be used to accelerate that migration. So being aware that we have some time, not a lot of time, I wanted to see if we could marry the convenience of IDaaS with the cost of an on-prem solution. So that's where the whole notion of bring your own identity as a service came from. And to do that, we started looking at DevOps, containerization, and all sorts of fun things. And honestly, that isn't as hard as you would think it is. So if you're intimidated by it, you really don't need to be. So let's take a look at what it takes to containerize something. So this is a Docker file, a really abstracted version of one, but at its coarsest level, you start with defining a base image. You do some things to prepare the operating system. You define the directory in which the application that's going to run the container will operate. You perform some additional work on the binaries to set up the application. You then run the commands to deploy and set up your Java environment and do everything. You configure your user and group who's going to run the application, and then you specify the actual process which is going to run inside of that container. Remember, a container isn't a virtual machine. It is an application running in an application container. So as long as that application is running, the container's up. If that process terminates, the container itself terminates. And in theory, your container hypervisor, your container solution manager, will then spawn a new container. So you plug this Docker file into Docker, and then you spit out Docker images. These images are the applications which are going to be running inside of your container platform. Forgive me for I'm going to start speaking about tools here, because in order to speak about this, we're going to have to talk about the tools we used. I went to the tools that I was passing familiar with, which were AWS and Ping. And so we had 3 different images which we used, and we deployed on Amazon. Now, getting back to the notion that a container is not a virtual machine, it's an application, that makes the networking considerations a little tricky. Not only do you need to worry about the inbound connections and the firewall rules for connections coming in, you also have to worry about how to make these containers communicate with each other when using software which wasn't necessarily designed to operate on a container. The software thinks it's actually running on nodes. So this gets pretty tricky really fast when you deploy in something like ECS. The networking modes inside of ECS define how those containers are going to operate with each other. The default one is something called AWS VPC. It treats each container as if it were its own default local host style mapped IP. That gets really hard to map using all the various interfaces there. So we scrapped it. This also starts a theme of making design concessions to achieve your ultimate goal. We opted to use the host method, so that way we could pass through the IP of the host on which the container was deployed. So that way the application would think and act as if it were running on its own instance, even though it was still containerized. Now the concession we had to do was we had to assign our size our containers to the size of the EC2 hosts on which they run in order to make this work, since the host networking mode only allows one IP. Now, if you're operating the enterprise, you're probably doing a VPC if you're using AWS. So the currency of the realm for network security inside of a VPC are VPC security groups. They just define which groups are able to connect on which ports for which items have those groups assigned to them. So this makes it very easy for you to manage which one of those containers running on those hosts are able to talk to each other both externally and externally. But one big problem, which is directly in conflict with running a global cluster, is VPCs are not respected across, security groups are not respected across VPCs. So what are we to do? Because the nature of ephemeral infrastructure is such that we'll never know the exact IP inside of our private subnet range for where we're going to deploy these things. So we whitelisted the VPC side of range for the VPCs in which we operate. And that may sound a little scary, but consider the entire notion of defense in depth. Though we made a concession for whitelisting the VPC side range for the private subnets in which our Docker containers could deploy, they were in a protected environment, protected through an environment which had vaulted credentials with a governed access control environment, and several additional layers of security. The point is, though you either don't know or you introduce a minor weakness in a security control, the point is, in order to achieve your ultimate goal, you counteract it by layering on additional ones. And at the end of this, I think you'll agree that it was worth the effort. So this gets us to the next things, now that we're solving some of the infrastructure problems, is that we have and solve for ephemeral infrastructure, but the IDP itself must remain consistent. There are secrets in place and relationships that need to last despite the environment going up, down, being destroyed and whatnot. So there's a fun thought process or a thought exercise called the ship of Theseus. And it goes like this, that a ship leaves port and goes on a journey, and over the course of its journey, it is slowly replaced piece by piece with other parts from other ships or new material. And so by the time it returns to port, not any piece of the original ship remains. So the question is, if that happens, is it still the original ship of Theseus? So if we're running an identity provider that is functionally wiped out at any given moment, is it still the original identity provider? And we have an answer for that, and it's yes, because we're storing its brains somewhere else, not inside of the ship. So we go ahead and write our containers to the registry where we keep our containers. When a new container is instantiated, the first thing we do is pull it from an encrypted S3 bucket. So on startup, it looks to there, pulls a zip file of all its configurations, and bootstraps that. So it remembers who it is on instantiation. Once it's running, at intervals, it does exports of its configuration as to make sure that any new changes are caught. So that way, the next time the environment is wiped or any event happens where the containers need to be refreshed, all the changes are maintained. So the next thing we need to worry about that we want to keep durable across an environment we don't care about is logs, right? Like I said, SSO and a single identity lets us have our security team get a nice view of identity and transactions across all of our systems. So we want to make sure to give them the tools for real-time logging for all the events happening in that environment. So we started streaming those to the Splunk endpoint for our SOC. But that got a little tricky because if we're streaming those out, we can't instantiate our containers and call a distinct logger as well. So that's another one of those little technical problems that you wouldn't expect to have. So we sidestep that by also running a parallel process by which we would copy our log folder at intervals to another encrypted S3 bucket, where then we were always keeping additional copies of that. So we could then aggregate it with our own log aggregator, because it would be inappropriate for engineers like us to have access to the SOC cert Splunk instance, excuse me. The next challenge is how do you deal with persistent data stores if you're happy to destroy everything at a moment's notice? Our environment keeps all of its OAuth clients and grants instead of a database. And since we're an OpenID Connect shop, or at least I have grand aspirations of making us an OpenID Connect shop, we need to make sure those stay intact. And what's more, Ping Federate itself encodes those stores using a string based on the DNS name of that database. And every time you reprovision that database, that DNS name introduces a new random number string inside of its name. So Route 53 to the rescue. We create an alias that is fixed, so that way there's always a durable DNS name that Ping Federate itself can look to and never gets spooked whenever the backend database itself gets destroyed. So this way we're able to use Route 53 to make sure all the persistent data stores remain persistent, even if they're really not. This also helps us bridge our on-prem DNS to our AWS DNS. So things like our federation endpoint is always going to be the same no matter what happens to our load balancers. Works great. So this brings me to my next point, is that consider your AWS tenant. There's only 5 elastic IPs there. IPs are a limited commodity. In an ephemeral and cloud-first world, DNS is the way forward. So you need to embrace and really get used to the notion of DNS itself as the way for you to recognize and connect to things. You can no longer rely on IPs. So now we have our environment. It spans 3 regions. People hit a single endpoint, and depending on where they are, they get routed to one of 9, 10, some number of nodes. Thanks to a geographic routing policy, folks in ASPAC or EMEA get routed to the cluster closest to them, so they have a positive user experience. And thanks to some neat features of Ping Federate itself, we're able to revalidate sessions and tokens for read-only transactions entirely within that subcluster in the region where they are at. This further improves performance to make sure that a token or a cookie or something does not need to be revalidated across the global cluster unless there's a new write function. I mean, the back-end connections for AWS are fast, but doing it entirely within the same region is much faster. So now in terms of failing over and making sure this thing is truly resilient, we started layering DNS and DNS routing policies on top of it. The first one is the geo-routing policy. That one doesn't refresh fast enough to fail over to a different region without me probably getting a phone call. So we layered an additional DNS alias with a weighted routing policy, so that way if there's a failure, the next load balancer and alias catches it, and that happens much faster than just waiting on that single geolocation-based policy. And of course, we do autoscaling. Due to some quirks of how we have to attach things to the load balancer, we do it based on CPU utilization, but luckily there's some guidance based on transactions that make those calculations pretty reasonable. In terms of high availability and disaster recovery, this model actually works out very, very well. The failover is pretty fast, and we ran a full battery of high availability and disaster recovery tests. And in fact, our RTO is about 9 minutes. We've done the exercises where we've destroyed the container, destroyed the region, destroyed 2 regions, destroyed the database, and it comes back on its own without intervention. It is more or less what we were really hoping it would be. And compared to the SLA for tier 0 applications at DR of 4 hours to recovery through the maintenance of a hot and active failover zone, it is way cheaper and way faster. So here's the real cool part. It's 100% infrastructure as code. This is our Git library, and we manage it through a single code base. We use a Python script, thanks to Sean, where we feed in parameters so that single code base can produce all the images and all the regions for dev, QA, prod, etc. So there's one single CloudFormation template, one single Docker file. We lean very heavily on parameterizations to keep our code base manageable and to really not have code bloat or get confused over which image is being produced or needs to be routed where. In fact, that Python file is capable of generating its own CloudFormation templates, well, not just the templates, but actually the change sets for full programmatic capability of deployment. That gets us to the point where we want to be able to commit changes directly in our Git and then have those pushes to master. And we're like 98% the way there. We just kind of have competing priorities to really make that dream come true right now. One of the fun side effects of containerizing an on-prem product is that product upgrades become surprisingly easy. And I know upgrading a product is often one of the more scary things somebody could do in the identity space. So really all we do is just diff the files that we touch in the new version, update those files, repackage them, and run our Python file. In terms of challenges, honestly, we're not experienced cloud developers, so there's a lot of rookie mistakes, not gonna lie. Some of them truly embarrassing, but nobody was harmed, so whatever. When everything is code, it lends itself to endless tinkering. It's very, very fun to create a fork, work on a feature, but before you know it, you have 20 features, and then a monstrous release that is very hard to do. Operational handoff is difficult. Now, I know I said we weren't gonna have ops, but much to my pleasant surprise, we got 3 of them. But then we designed it not to need ops. So as they got involved, well, they weren't really prepared for engineering type tasks. So that handoff got a little more tricky. And I'm sure if I could do it all again, I'd probably prefer something a little more portable than relying on ECS. So let's take a look at the impact. So compared to on-prem, cloud-hosted on-prem or IDaaS, building your own IDaaS hits everything we care about, and in that all-important cost metric, it blows it all away. And remember, it's always important to tie what we do to things the business appreciates. The total cost of ownership on this is significantly less than our current systems it's replacing. Comparing apples to apples for IDaaS, it is $2.2 million cheaper to run per year compared to retail IDaaS. And since nobody pays retail, it is $700,000 cheaper to run per year compared to a best in final offer for comparable services through a leading IDaaS provider. And we open sourced it. So our hope is that you can take a look at it, find the vaults, ideally, improve it, so that way we can all learn and grow together. It's on there too. Any questions?
We have about 3.5 minutes for questions.
I'd heard what ping federate are we on? We are on 923. When we started in March, it was 903. So again, staying up to date is pretty easy when you've containerized it. Matt.
What aspects of the application, like versus others?
So the question was, what aspects of an application lend themselves to running a container versus those that do not? I'm going to say, again, I still don't think I'm a container wizard or a Docker wizard at all, but I still don't fathom how anything that would make deep registry hooks like in Windows could run in a container successfully. Things that are capable of operating with minimal environment parameters are probably going to be more successful. I think that is probably the 2 biggest parameters I can think of off the top of my head right now.
Where you stored the attributes of the users? I haven't seen the containers with that.
So the user attributes are stored inside of our directory services, which I was not responsible for, but we reach back and touch. We use a virtual directory view, since we're not in the cloud yet. Question is, what do we use for the directory? We use Radiant Logic Virtual Directory.
Next. So I think I saw that your container was Ubuntu 18.04, right? Or did you make a ping federate container that just is running ping federate? So is your container just is an operating system with ping on it, or is your container just ping federate?
I guess evidently my container is running on 18.04 as the base image. And this, again, comes from, there was a dearth of guidance when I started, literally nothing. And the one piece of guidance I got was a reference inside of ping documentation somewhere that said if it's going to run on container, the host needs to be Ubuntu 18.04. And now, as I understand it, they've produced their own reference templates, so that could be something we could reevaluate.
Did you guys look at replacing ping with any open source IDP as part of that project? We have not, but the beauty part is, because of this, in theory we could. And that's kind of the entire point. I mean, not to suggest that we're disinterested or ungrateful to Ping for the great partnership they've offered us, but from an enterprise perspective, it's important that we always have the capability to remain agile. And so other open source products, which I'm aware of a few, which definitely lend themselves well to containerization, I mean, at some future hypothetical date could be dropped in Ping's place if that day ever comes.
All right, we have time for one more question.
Over there.
Thank you. So for the multi-region architecture, for the token repository, how do you manage? Like, do you move users to one region always? Because you got to have a right, wherever you are storing your tokens. So how is that managed?
So
just for the multi-region architecture. Yeah.
So users are routed to a single region. For write events, the cluster has to achieve consensus for that initial session. For any refresh, they only need to achieve consensus for that one session. In theory, the user will only be routed to the geographic region where they're at due to the geolocation routing. In terms of writing the session and keeping track of the grants, those are written to a data store, which presently is kept inside a single region. But once we were able to switch that to multi-master in a way that is not a tremendous pain, the plan is obviously multi-master.
Thanks, John. Thanks, everyone.